Imagine this scenario. It's midnight. You're a founder or a product manager, and you have a mounting list of feature requests, bugs, and release deadlines. Your engineering team is asleep, and your backlog is growing. You close your laptop, but while you sleep, a quiet, local software factory wakes up on your developer machine. It doesn't use expensive hosted cloud services. It doesn't leak your private codebase. It runs locally, utilizing the standard CLI subscriptions you already pay for. By 3:42 a.m., a fully complete, peer-reviewed, and cryptographically verified pull request shows up in your GitHub repository. The features are built, the bugs are fixed, the tests are passing, and an auditor has stamped it with a secure seal of approval. This is not a far-fetched dream of the future. This is the reality of ao-operator and ao-runtime. For the non-technical people watching, think of this like a fully automated building site. Instead of hiring one generic builder and asking them to plan, lay bricks, install plumbing, check electrical safety, and sign off the building alone, ao-operator sets up a disciplined team of specialized workers. For the technical folks, this is the first local, deterministic agent workflow orchestrator that converts a high-level natural language spec into strict role contracts, workspace sandboxes, and obligation-based evaluator closure gates. Today, we're going to pull back the curtain and show you how easily you can automate your software production pipeline locally, safely, and for zero extra token cost. If you've ever tried using AI to write code, you've probably felt the chat window tax. You open a prompt box, you paste a file and ask the AI to add a button. It does it. Great. Then you ask it to connect that button to a database. But in doing so, the AI forgets the security rule you explained in your very first prompt. It deletes a piece of core middleware. It hallucinating APIs that don't exist. By your fourth message, the chat context is bloated, the AI is confused, and you end up reverse engineering its mistakes. You're no longer writing code, you're babysitting a chat box. On the other end of the spectrum, we have hosted agent platforms. These are cloud-based black boxes. To use them, you have to hand over your private GitHub keys, allow their servers to run arbitrary code on your codebase, and pay exorbitant per token fees. You have zero visibility into what the AI is doing, no local sandbox, and a massive vendor lock-in. This is the exact problem ao-operator solves. Instead of treating AI like a single distracted assistant in a browser tab, ao-operator treats AI like an assembly line. It splits a single task into a sequential pipeline of highly restricted, role-disciplined agents. And because it runs locally, it hooks directly into your existing command line logins for tools like Codex or Claude Code. You don't need to configure fragile, expensive API keys. If you already have a local developer setup, your factory is free to run. You get the structure of an enterprise software factory with the absolute safety of local execution. Let's look under the hood. How does ao-operator organize this assembly line? For the non-technical audience, think of this like a rigorous corporate workflow. You don't let the builder inspect their own work and write their own invoice. You have a general manager, a builder, a quality inspector, and a finance manager who signs the check. Each has a strict job. In ao-operator, this is called the RE team's operating discipline. It defines 5 core roles. First is intake. This agent clarifies the goal, defines non-goals, catches vague assumptions, and stops a messy prompt from becoming a messy patch. Second is planner. It takes the intake spec and writes a strict, minimal blueprint. It defines exactly what files the AI is allowed to touch. Third is the implementer. It does the coding, but it operates inside an isolated sandbox, seeing only the files authorized by the planner. It doesn't get flooded with the whole codebase. Fourth is the reviewer. This is an adversarial check. It actively tries to find security vulnerabilities, edge cases, and compliance failures in the code. Finally, the evaluator closer signs off. All of this is bound together by 2 files on your disk, the run spec and the evidence pack. The run spec is the deterministic contract. It is a simple YAML file that defines who did what, which model ran, and what policy was applied. You can share this file with a colleague, and their local machine can repeat the exact same run. The evidence pack is the sealed record of completion. It collects every prompt, every CLI output, and every test log. The closer doesn't approve the task because the AI claimed it was finished. It approves because the physical evidence is written in the pack. This brings us to the core philosophy of safe automation. Done is a file, not a vibe. If you've played with standard AI tools, you've seen them say, "I have successfully fixed the bug," only for you to run the code and find it immediately crashes. The AI has an optimistic vibe of completion, but no hard proof. ao-operator replaces this optimism with the obligation ledger. When you ingest an engineering spec or product brief, ao-operator parses it and extracts a hard list of obligations. These are direct rules that must be true. For example, must parse financial citations in SEC format or must throw an error if the database connection fails. These are written into a structured JSON ledger on your disk. Before the evaluator closer is allowed to sign off, a verification script runs against the codebase. If any single obligation is marked failed or remains unverified, the closer immediately blocks the run. On your screen right now, you can see a visual representation of this ledger. The green checks indicate items that pass the automated test suite and peer review. The bright red banner highlights a critical violation. A required cross-reference check was skipped. The orchestrator instantly stops the pipeline, highlights the exact line of code that caused the failure, and writes the error to the status directory. For non-technical leaders, this means absolute governance. You can set product compliance guidelines, and the AI cannot bypass them. For developers, this means no regression bugs and zero guesswork. You don't have to trace a long chat transcript to find where the AI went off track. You open the file, inspect the failed obligation, make the necessary adjustment, and resume the run. As your software needs grow, ao-operator scales beyond a single script on a single machine. Through ao-runtime, the operator can coordinate across different operating systems. As you see on the screen, a single task brief can be split run across a macOS development host, an Ubuntu container, and a native Windows server. They work in unison, testing cross-platform build compliance, database migrations, and UI rendering simultaneously. ao-runtime handles the workspaces, the isolation boundaries, the policy enforcement, and the cryptographic keys. If you want a chat interface to collaborate with the team, you can layer OpenClaw on top to submit and schedule runs. If you want to saturate multiple worker machines overnight to burn through a massive queue of security patches, you can hook in Herms to manage the queue. But underneath, the role contracts, the security gates, and the obligation ledgers remain perfectly intact. Whether you are a founder looking to accelerate your product releases, a product manager wanting a reliable prototype builder, or a senior engineer who wants to stop writing boilerplate code and focus on architecture, ao-operator gives you a disciplined software factory on your own terms. You can try it tonight for free. Navigate to the repository, copy the single command in the README, and paste it into your local terminal. Run the provider-free smoke test, inspect the generated run spec, and see the role graph build right before your eyes. Automate safely, enforce accountability, get work done. Download ao-operator and start running your local software factory tonight.